Hey YouTube, what's up? Dr. T here in St. Petersburg, Florida. So here part 2 of my edited presentation from NVIDIA's GPU Japan 2017.
Let me show you what it's like to run deep learning on NVIDIA's VOLTA. Thanks, Paul. So the TensorRT takes this computational graph and runs it through an optimizing compiler and outputs a VOLTA CUDA program. This VOLTA CUDA program was written by software. So software wrote software. And this VOLTA CUDA program for a deep neural network could predict many things. Depends on what you taught it to do. The performance that we've been able to achieve is nothing short of amazing. If you were to use TensorFlow, which is Google's AI framework, and take the output and run it on the fastest CPU for images per second, ResNet, which is a relatively small network, is 140 images per second. On V100 with TensorRT, it's 5,700, 40 times the speed up. For natural language translation, from English to Chinese, from English to German, Germans to French, all these different natural language, it's called Open NMT, Natural Machine Translation. A CPU runs at 4 sentences per second, and V100 with TensorRT, 100 times faster. Now, looking at bar charts is very impressive. However, ultimately, what you buy are servers. This is what it looks like when you want to run 45,000 images per second. Now remember, 45,000 images per second is not that much. And the reason for that is because you have mobile customers all over the world. You have mobile customers all over Japan. And they're maybe doing a image recognition request. They're taking a picture and saying, what is this product? I want to buy it. Millions of people are using their cell phones at the same time. And so 45,000 images per second happens all the time. And with 45,000 images per second, it would take 160 CPUs and 65,000 watts to achieve. Okay? 160 CPUs, 65,000 watts. That's basically 4 racks. 1, 2, 3, 4 racks. So 4 racks of servers would allow you to inference, predict, recognize 45,000 images per second. Well, if you were to do that with VOLTA, it would look like this. This is what it would look like with VOLTA. With NVIDIA's VOLTA, all it would take is one server with 8 GPUs inside, 45,000 images per second, and it only consumes 3,000 watts. 3,000 watts. 1/6 the cost, 1/20th the power, 4 racks in just one box. The more GPUs you buy, the more money you save. So this is the miracle. This is the miracle of deep learning. First of all, these are flowers, of course. You recognize that these are flowers. But very few of you can recognize exactly what the flower is. And so Ryan, let's take a look at this. What flowers are we looking at? Okay, so that's a pincushion flower. That is a love in the mist, okay? That's a water lily, I knew that. And that's a bromelia. Now this is a CPU, this is the latest generation CPU. It's running at about 5 images per second. 5 images per second. That means 5 different consumers on their mobile phone can request, what is this flower? And in 1 second, this CPU will return the results to those 5 people. But as you know, how many people are in mobile cloud? This 7,000 images per second is running on 8 VOLTA GPUs. So what you're looking at is this. This box right here, this is the NVIDIA DGX1. There are 8 VOLTAs inside. This one box is doing this for 7,000 people. For 7,000 people. Another way to say it is it only takes 1,000 boxes. 1,000 boxes for 7 billion people. Unbelievable. Unbelievable. The more GPUs you buy, the more money you save. Okay, but the amazing thing is this. This is what's amazing. Remember, this is 2,000. This is 7,000. And the original, go back to the CPU. Take your time. And so this, remember, 7,000 is that one box. One CPU is 5. 2 CPU, which is 1 server node, is 10. 1 server node versus 1 DGX, 700 times slower. 700 times. Let's divide that by 40 for simple math, because each rack of server is somewhere between 30 to 40. So 20 racks. The more GPUs you buy, the more money you save. Okay, thank you. It's very simple. Several billion dollars of R&D, enormous amounts of invention, the more money you save, okay? And so that's VOLTA. Ryan, thank you very much.
Anytime.
So we'll break here from part 2 and come back with part 3.